Stratosphere, its range up to 11 to 50 kilometers, but the temperature would be varying between minus 56.5 to minus 2.5 degrees Celsius. Okay, this is the location where actually your weather balloons are being flown. Okay, whereas you see the troposphere between 0 to 12 or a max to 18 kilometers, the troposphere will become thinner and thinner as we climb higher. Uh, that location where you will have a hot air balloons or your aircraft, the civilian aircrafts or a passenger planes, where actually flies. Okay, whereas in stratosphere you will see weather balloons or even fighter jets can go into up to the stratosphere also. As you climb above 50 kilometers, you will end up into the mesosphere, which is actually a place where you will see the rockets and the meteors and all those things. You will see where the temperature would be between minus 2.5 to 80, minus 86.5 degrees Celsius. Whereas as you climb above 80, 90 kilometers, okay, so somewhere between 90 kilometers to 800 kilometers, that is the location where you will actually see the thermosphere, where temperature will be little bit more uh, hotter, I would say. Okay, and that is the location where you will, because of the ionization of the particles and all the things, you will see auroras and all those things happening in the northern hemisphere near Norway and all the things, or maybe in southern hemisphere in Antarctica locations also. As you climb beyond 800 kilometers up to 3000 kilometers, uh, probably that is the area where we called as exosphere, and your satellites and international space station and other satellites which are moving across the sky, uh, you will be seeing in this particular zone. Okay, so that's how your atmosphere is divided into different layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And most important, we have to see that the pressure, temperature, humidity, and density. So if you start at the ground zero, your temperature probably would be 15 degree. But as you climb up and up and up, like you go to a higher hill station. Why do we go to hill station? Because they are colder. So as we climb above the ground or above the sea level, so the 15-degree temperature what we are talking is a standard temperature at the sea level. Okay, so at a sea level you may be having 15 degree, but as you climb up, your temperature will start dropping. So as you climb 1000 meters, 2000 meters, 10,000 meters, you see like Everest, as you climb higher and higher, the pressure and the temperature as well as the humidity and density changes or varies as we change ourselves vertically in the distance. So weather is the state of atmosphere describing, for example, the degree to which it is hot, cold, wet, dry, calm, stormy, clear, or cloudy. Like if you see yesterday when we were the same time we were doing the session, it was very bright sunny. Okay, whereas today the climate has become little bit gloomy, okay, or cloudy. Right? You can see the difference in the weather and yesterday's weather. Okay. So weather is one of the factor in the modern aviation over which man has no control. Though we have so much of technology, so much of data and everything, still a lot of time you would have seen our forecast goes wrong. Okay, so how are we forecasting? Basically on our historical data. These weather stations, they might be having a huge amount of data. Like they would almost have almost like 50, 60, 100 years of data available with them, because weather stations were established very long time ago. Okay, so a lot of places you'll see weather stations, they're having a very old legacy, and they've been formed and they're keeping records of the weather based on the date, time. They will have a lot of historical data available, and based on that data they will try to forecast the weather. Okay, but not necessary the weather, whatever the forecasted weather would be same, because the four parameters what we see here, the pressure, temperature, density, and humidity, can change. These four parameters can change, and then can differentiate. You will have a different weather. Again, if you see whatever the weather you are seeing here in Mumbai today, it may be feeling cloudy, but as you go towards maybe Surat, might be sunny, or maybe in Ahmedabad it might be a sunny weather. Like even you call someone and ask how is the weather there in probably Ahmedabad or Jaipur or even Delhi, the weather would be different. So every 40 kilometers, 40 50 kilometers or maybe 100 kilometers, the weather would change, or the way the weather is there, there would be a change, slight changes will be there, or drastic changes will be there, depending upon how the weather is been forming over the location. Okay. So meteorological is a branch of the atmospheric science which includes atmospheric chemistry and atmospheric physics, with major focus on weather forecasting. To understand the meteorological hazards, their effects on the aircraft, and how to minimize the risk posed by these hazards. To identify the weather information that is required for each flight to interpret actual and forecast weather conditions from the documentation provided. To analyze and evaluate weather information before flight and in flight. A knowledge of meteorology will at least enable the aviators to anticipate some of the difficulties which weather may cause. So as a pilot, let's say for example, I am flying an aeroplane. I am carrying a Boeing aeroplane or Airbus. Along with me, I would be carrying almost 200 plus passengers. So I need to make sure that my flight or my flight plan, whatever I have planned or desired, it should be a safe. So I need to study the weather over the course of my flight plan. So I will see, okay, I am flying from Mumbai over the coast, towards Surat, Vadodara, Ahmedabad, then Jaipur, and then Delhi. Okay. So in that scenario, I will see what are the weather patterns do I have. I will see the 1 day prior weather, maybe last 7 days, how was the weather. Probably I would see the forecast, forecast based on the data, what would be available. Okay, so this information you require so that you plan things better. You should plan like what height you will be flying the plane, what location you will be flying, how the location is there, based on your experience and your based on the data what is available with respect to the airports or with respect to the locations on your flight plan. And then you need to have emergency plans in case of any change in the weather, because a lot of time we see that, okay, weather, we may forecast that, okay, weather was very bright, sunny and everything. Okay, I'll tell you, last year I have gone to Chennai, okay, for my one of my trainings. And that time there was a launch of a mission called Aditya L1. Okay, I hope everybody knows what is Aditya L1. Okay, so that's a satellite which is sent into the space by ISRO to monitor the sun. Okay, so they have launched. They actually, it was delayed. Okay, it was delayed by 2 days or something like that, and they decided. And that day, in the morning, the weather was very very clear. I mean, it was a crystal clear. We saw the launch, we saw everything. And that day itself, in the evening, 4 o'clock, it was heavily raining at that location. Heavily raining. So you see the change in the weather. So the ISRO took the decision to launch the satellite because weather was good on that day in the early morning. So somewhere around 11 o'clock, the rockets were launched, and the satellite was put into the mission, okay, or in the orbit. But same day, after 4 5 hours, the weather was completely in a different manner itself. It was heavily raining. In fact, I was supposed to travel back to my home, and I got stuck up. It was like, it was 2 hours. It was continuously raining like anything. Matlab, we didn't have any plans. It was not thought about it that there would be such drastic change in the weather. Nobody thought about it, and all of a sudden the weather changed. Okay, so whole plan of travel got disrupted. I have to stay back and take a next day flight or something like that. I have to plan out, and then accordingly, that's it. So when we are flying, uh, especially the civilian airplanes and all the things, based on the distance and location, we need to study the weather. We should be ready in case of any kind of weather could impacting my flight plan. Okay, so to how do you know what could be the weather, or what is the weather currently at, let's say, Ahmedabad? What is the weather currently at my Mumbai airport, or what could be the weather at Surat airport, or what could be the weather where I'm going to land my plane? So there is something called as METAR. METAR is nothing but meteorological aerodrome report. That means this report is being generated by every airport or every aerodrome. Okay, so they will generate this report every 8 hours or something like that, which they will give the current status of the weather, and then they will forecast the weather for next 4 hours or something like that. Okay, so based on different uh, uh, people over there who are deployed for generating this kind of, there would be a person who would be responsible for generating this kind of data, who will be publishing. So earlier this data was available to the pilot on their panel, okay, in a very crisp small text kind of phraseology. Whereas now, because of advancement of technology and all those things, every location would have its own website. So METAR would be available for anybody. So yes, Hari, it will be available to anybody. I will just show you how and to see the METAR. Okay. So you go to Google and just type METAR for Mumbai Airport. Okay. So you can see here. You will see here. This is a METAR. Okay. So ideally, the METAR would be earlier was displayed in this format. You can see here. So this is the location VABB. Okay. So VABB is Victor Alpha Bravo Bravo. That is the location. Okay, Mumbai. So you see Mumbai, India, Chhatrapati Shivaji International Airport. What is latitude 19 degree, as I told you, longitude 72 degree, elevation. Now you see the elevation of the Mumbai airport with respect to the sea level, it's 8 meters. Okay, so report was made in India knots from the east direction. Temperature is 33 degree, humidity is 34, pressure is standard pressure. You have 108 hectopascal. Visibility is 300 meters, sorry, 3000 meters. That means up to 3 kilometers you have a visibility, but beyond 3000 meters you do not have a visibility. Then you can see scattered clouds at height of 2000. So there are low lying clouds are there, broken clouds at height of 10,000. Okay, then you're feeling like a smoke, like the weather is like a smoky kind of thing. Okay, forecast. Now if you see the forecast was like wind could be slower, wind would be 16 knots, visibility would be same, almost 3000 meters, scattered clouds, again broken clouds, climate would be hazy, becoming, again the wind may increase to 12 knots, visibility may improve from 3000 to 4000. So this is how you see the METAR, okay, for Mumbai airport. Let's see the METAR for any other location. Okay, now this is Indira Gandhi International Airport. Okay, latitude is 28 to 34 north, longitude is 77, elevation you see it is Mumbai. Mumbai airport was 8 meters, whereas Indira Gandhi International Airport is 220 meters above the sea level. Okay, wind is flowing 8 knots from west direction, whereas for Mumbai it was 8 knots from east direction. So you see the change in the direction of the wind and the speed of the wind also. Then you see temperature is 32 degree, whereas here temperature was 33 degree. Humidity is 15 degree at Indira Gandhi International Airport, Delhi, whereas here humidity was 34. So you see a lot of hot in Mumbai. Okay, you will sweat in this climate, whereas if you see here, it is not that much. It's cold. Still, it is good climate over here. Pressure is again standard 10112. Visibility, see, because of the temperature and the difference in the humidity, you see the visibility is better. Okay, 6000 meters, that means almost 6 kilometers, almost 6 kilometers you can see currently. Whereas if you see the forecast, this is the METAR normally what would be available in earlier days. This is what basically the pilot needs to read, like see here 6000 visibility or wind at 8 knots. or what time this was generated, no significance change, or the pressure. Okay, what would be the standard pressure 10112, or the temperature 32 and 02. Okay, so all that information used to come in this format earlier, but because of advancement of the technology, we can get the METAR report now directly in a readable format or easy to understand the format. Okay. So if you see the forecast here, wind would be around 6 knots. Visibility could reduce from 6,000 to 4,000. It could be haze, and then you can see, like, they have just put a forecast for different timings. So that's how you can know the METAR for the particular location. We can try to see for Surat. Just a minute, I'm getting a call. You can see how the METAR for Surat airport is been defined. Okay. So this is very standard way of presenting the METAR, but some airports normally have some different way of putting the metadata over here. You can see 32-degree temperature, smoky, 5 knots of wing, 4 kilometers of visibility, then maybe not a cloudy. Okay, we can check this on meteorological website also on IMD. Okay, if you go here, you will get a satellite data also. You can see a satellite image over here. Okay, you can see the satellite image. Now, if you see, click on the satellite, you will get a bigger picture. You see here, this part is more or less cloudy. That's why we see the temperature. But whereas if you see Gujarat, Rajasthan, even Delhi location, these are all pretty clear. This completely black. So that means what? It's a clear weather here. Okay, here it will be clear weather. Even you see Bangalore, Karnataka, the Telangana, or even Orissa, Andhra Pradesh, and little bit cloudy you see here in Kerala and what is that, Tamil Nadu locations. Okay, but whereas in middle part, this part and the upper part, northern part of the India probably had. But then as you climb up in Kashmir and Ladakh, you can again see the clouds, right? That's how the weather is there currently. This is the live data with respect. This has at what time? Uh, Morning, I think 6 o'clock. Okay. No, it is at 11:42. So very latest data it is. IST. Okay. So 11:42. So clear on the weather, you can practically see the actual weather the way currently it is there on our country. Okay, whereas you see on the sea is very clear. There is no clouds in the sea. But whereas you see in the southern part, in the Indian Ocean, you can see a lot of clouds over here. Okay, but whereas you see in the Arabian Sea, there is nothing. It is a crystal clear. So good for sailing and all that kind of all those other activities. Only you see on the land part, okay, or the land mass or the terrain part, you will see clouds formation or cloud happening at this. So if you observe this over the period of now, next couple of months, you will see a lot of clouds getting formed over here, and then we'll be transferring over the land mass. Okay, and if you see in monsoon, this will be completely covered by the clouds. Okay, that's how you regularly study. So I think every 8 hours, they change the satellite image over here, so that you get real time data about the weather on your particular country. Okay, so this is our Indian government website, IMD. Normally we call it as Indian Meteorological Department. So they publish data regularly. You can see here if you click here, any of this You can see the motion of the cloud also. You can see the historical data, like how the clouds motions they are showing, right? Sometimes this website is little bit loaded because a lot of people who would be using this for their information and for their data also. You can see here. See the cloud motions. So they have the satellites are capturing data on regular basis. So they have this data, so they can see the patterns and the motions of the clouds, and based on that they can predict where what could be the type of uh, weather would be there based on those four parameters: temperature, pressure, humidity, and density. Okay, clear? Any questions on this? No. So for drone operation, we need to cross check the METAR for safe and secure operation where we don't risk the drone. So basically, METARs give us the information with respect to the wind direction, wind speed, the temperature, humidity, visibility, all that information what is required for safe flying. The METAR would give that information pre-hand. Okay, so not only about your current location or current site, like Mumbai airport, but also whatever the operations, like if you are flying a civilian airplane from Mumbai to Delhi or Mumbai to Chennai or Mumbai to Hyderabad, based on that location or that flight path, you need to understand study the METARs, okay, of that particular locations. For drone operation, we need to cross check the METAR for safe and secure operation, because currently our operation is limited within certain distance. Okay, like we are flying drone only under visual line of sight, so probably we may be flying drone within, let's say, max 3 kilometers range, 2 to 3 kilometers of range. In that range, the weather would not change so drastically. Whatever weather you are feeling at that point where of your launch would be the same weather, probably 1 kilometer far. Okay, it is not going to change much. Okay, but there are other components like wind might play a role in that. Okay, so wind is the most important parameters when we are flying a drone, because drone is not actually a aircraft which is designed. I mean, I'm talking, when I'm talking about drone, I'm talking primarily from a rotorcraft perspective. Okay, since we are going to get trained under the rotorcraft. Okay, so we will come to know about what would be the safe conditions. Like we'll see in the wind section when we come to the topic, what is the safe wind we should be flying over drone. Okay, so let's understand what are the components of the weather and how they are affecting and what would be the type of weathers we need to know. Okay, so METAR, for METAR, you, as I said, basic was actually go to the every airport website and get the metadata. But there are a lot of apps which are available. You can download on your mobile, and you can see the forecast. There are forecasts for a next day. There are forecasts for next 3 days or 7 days, kind of thing. Even a month's forecast are also available. So like UV forecast, good to fly, drone cast, drone buddy, air data, UV. I have seen a lot of time the pilots are been using the Windy platform. This is more accurate, I would say. Even I personally use Windy on my mobile whenever I have to check what kind of weather would be available at that particular location or that particular day. Okay. So as we talked about the different parameters, the first is the pressure. Okay, so international standard atmosphere. The international standard atmosphere is a static atmosphere model of how the pressure, temperature, and density and viscosity of Earth atmosphere changes over a wide range of altitudes and elevations. So there is a some standardization is done basically at what level, what could be the pressure, what could be the temperature. So we need to have some reference point. So international organization has standardized the standard atmospheres settings. Okay, so it has been established to provide a common reference for temperature and pressure and consist of tables of values at various altitudes plus some formulas by which those values were derived. So this metrology in itself is a big topic. When you are doing a study of CPL, when you are becoming a commercial pilot, metrology in itself is a subject to study. So where you will be given a book. It's a complete book, 300 and plus pages of book only on metrology. Okay, it's by Indian author IC Joshi. Okay, so the topic is about completely about metrology. So in that you will see all these tables, how to calculate the values based on the different location, time, or the temperature, what could be the pressure, density, and all that. So combinations of all these parameters, you can derive a standard settings or standard values for the particular locations. So what are the standards defined by the ICAO? So ICAO publishes their standards atmospheres is like at mean sea level, the temperature would be always 15 degrees. So 15 degree is a standard temperature what is setting. Not necessary it will be always very accurate at 15 degree, but this is some approximations they have taken, and they have said that at a mean sea level the temperature would be 15 degree. At mean sea level pressure would be 1013.25 hectopascal. Okay, what would be the density at mean sea level? The density at the mean sea level will be 1225 grams per cubic meter. Okay, and what would be the lapse rate? I mean, how the temperature would change. Okay, so the lapse rate would be 1.98 degree Celsius every 1,000 feet up to 11 kilometers. That means up to 1100 11,000 11,000 meters. Okay, so practically we'll use rounding of the lapse rate like every 2 kilometers. Like for example, right now I'm at Mumbai location, so my sea level, my temperature would be 15 degree. If I climb 100 feet up, probably I go to Lonavala, the temperature would be 13 degree. If I climb further up 2,000 feet, the temperature would be 11 degree. So that's how the temperature would reduce. That will reduce up to 11 kilometers. Okay, that's how the difference would be there in the temperature. So the higher you climb, like you go to Kodai Canal, 8,000 feet, so temperature will be so cold over there, or even Everest location. Okay, or any hill station, like you go to Mahabaleshwar. Okay, so Mahabaleshwar is around 1,500 feet. So that location you will feel much cooler compared to what you see in Mumbai because of this standardization. This is basically standardization to understand, like if I am 1,000 feet up from the sea level, the temperature at that location would be 13 degree. I am 2,000 feet from my sea level, the temperature would be 11 degree kind of. So type of pressures, yesterday we have seen this in topic of our ATC procedures. In aviation community term, QNE, QNH and QFE are used to describe the standard pressure, local altimeter and the field elevation respectively. Yes. So basically, there are two requirements when we are flying the commercial airplane at a very high location, because it will give you a fuel efficiency. Okay, and then you will have a less disturbance. Okay, of any other the thing. So the sky would be much more clearer. You will not have the air resistance more, so you get a better efficiency when you are flying at almost like 30,000 feet high. So the longer flights, like you're flying from, let's say, UK to Sydney, the longer flights, you will probably always fly in a very higher, warmer path of the atmosphere. Okay, whereas if you fly closer to the ground, your density would be more, the pressure would be more, all that things, the temperature would be again more and all the things. So basically, to just to compensate and get a better fuel efficiency, you will always fly at the higher altitudes. Clear? Okay, so coming back to the types of pressures, the QFE, what we have seen, the field elevation. Okay, the QFE is altimeter pressure taken setting at the takeoff location, which indicates the height. So this is what we have said. We are always refer to QFE when we are flying a drone. Whereas the QNH is nothing but nautical height. It is a QNH is altimeter pressure setting takeoff reduced to MSL. Okay, under the ISI condition, which could indicates altitude. The QNE is the altimeter pressure setting at a standard atmospheric pressure, which indicates the flight level. So this is basically in the mid of the sea levels. We will be talking about QNE, whereas QNH will be talking when we are actually at a location where we can know what is the mean sea level at that particular location. So in that scenario, we'll talk about the nautical height or maybe the altitude of our flight. Whereas when we are in the middle of the sea and the thing, that time we'll talk with respect to the standard atmospheric pressure, which basically we indicates it as a flight level. But on the terrain, or let's say for example near to the airport or any terrain location, we'll definitely always use as a QFE, which is a field elevation. Okay, we'll see in the next slide in a pictorial form. So you can see here, this is what we call with respect to the sea level, this is the altitude. Okay, with respect to the what we is standard pressure, we call it as a flight level. But with respect to the land or the aerodrome or aeroport, we'll normally call it as a height or field elevation. QFE, QNE and QNH. So nautical height, nautical elevation or flight level, or field elevation, what we call it. Okay. Again, another way of explaining. I mean, we have just kept a couple of slides so that sometimes people are not able to visualize the distance or understanding the QFA or QNE and QFE and all. Okay. So any questions on this? I hope now this is very clear, when to call for QFE, when to call for QNE, and when to call for QNH. This is specifically from the civil aviation or the aviation perspective. From the drone perspective, we are only following QFE as of now. Okay. So now, after the pressure, the another aspect of the parameter is wind. So to measure the wind, we use a device called anemometer. Okay, so anemometer is a device. So earlier there was an analog anemometer where you would have seen it a lot of places. You know, those four cups which actually rotates as the wind flows, and that what motion, the circular motion, there is a gear, and in below there is a, the readings which it will show that at what speed the wind is flowing. Okay, now in recent times, because of advancement of technology and all the things, we have digital anemometer, so it converts the analog signal into the digital format. So this is a very simple device, pocket size. It is available on Amazon. It not cost something between 300 rupees to 500 rupees. Okay, so this digital handheld anemometer are available in market. where drone pilot must always. So basically, wind is the only important aspect which could affect your drone. So normally we'll always have this device available with us whenever we are doing our flying or things. So we can always cross check the direction of the wind and the speed of the wind. Okay, the wind speed should not be more than permitted limit by the manufacturer at the time of the drone opening. So depending upon your drone, for example, you're flying a DJI drone, so you need to check what is their manual prescribing. Like DJI Mavic is there, DJI Inspire is there, or DJI Matrix is there. So every drone will have its own withstanding limit of the wind. Okay, but I'll tell you what is the standard to follow when we are flying any sort of drones. Okay, so you will see most of the places like airports, aerodromes, or even drone flying training schools locations. You will see a windsock. Okay, so this is a very simple device which will help to you to understand the direction of the wind and the amount of wind it is flowing. Okay, so normally these are five sections over there: red, yellow, red, white, red, again like this. So there are five sections: the first, second, third, fourth, and fifth. So when all sections are down, okay, all the five sections are down, probably there could be a no wind flowing. So as wind is flowing, if the only first section is in horizontal position, that is where we say it is 3 knots of wind is flowing. You see there are four sections are not horizontal, they are bent. Okay, so as you see two sections are in horizontal position, it will be 6 knots. Three, it will be 9 knots. So it is a multiple of three. So depending upon how many sections do you see, multiply by 3. So here you can see all five sections are in a horizontal position. You can see 5 threes are 15. So 15 knots. So if the wind is flowing above 15 knots, you should not fly your drone. You should avoid, or you should wait for some time. Okay, you can see the direction on the direction of the cone also. So direction of the cone will give you the direction of the wind, from which direction the wind is flowing. Based on that direction you can know what is it, and then accordingly the sections which are horizontal, you can know the speed of the wind also. So if your wind is more than, like if it is completely horizontal, you should make sure that you are not flying the drone. If you are flying the drone and the wind is started flowing at 15 knots, you should immediately take a precautionary measure to land the drone, uh, and make sure your drone is safe. Clear? I think, Hari, are you clear in what normally people follow? Like probably above 15 knots, people try to avoid flying the drones. But for
Very
aeroplane
much.
or thing, it's not really matters. Okay, so there might be somewhere around 20, 22 knots. Even people fly aeroplanes. Okay, because the aeroplane is a big wing structure and they are aerodynamically designed. Okay, whereas the quadcopters or the normal drones what we fly, they are not aerodynamically designed. So a lot of time, it will, the wind, the higher the wind speed will always impact the stability of the drone. So basically the current new drones, they have a very advanced technology. So every time there is a push on the drone based on the GPS. If you are put at a particular location, you are put on a hold position of the drone, the drone will always try to stabilize at that position, because drone is having a loitering or hovering function available. So based on that inputs, it will try to compute and try to compensate by changing the speed of the propellers. Okay, good. So lot of time, out of the curiosity, we would have seen this windsock flowing lot of locations, like even on the weather stations, airports, aerodromes, or even some important some locations they put it. Wherever they need to know what is the wind speed and all. So a lot of people put it. But nobody thought about how to get the information for that. I think hope now looking at this picture now it is clear. Like once you see the windsock and seeing the position of the sections, you will able to tell how much wind speed would be there. Clear?
Yes.
Okay. Okay, so now we'll see how the wind flows. Okay, so there are what are the different flow of the winds called. Okay, so gust is a sudden increase in wind speed, often with the change in direction, lasting less than 1 minute, and it is a local effect. Like a lot of time when we are standing in open ground, all of a sudden we feel the wind pressure or wind speed. You know the pressure of the wind on our body. So that is nothing but is a gust. If it is lasting less than 1 minute, and it is a local effect, that means even the person standing probably 500 meters away, he may not be having the same effect of the wind on him. Okay, so that is a local effect. Okay, so at some location only you will see all of a sudden the wind flow you will see, and you will feel that wind flowing, and all of a sudden it will stop because it will be less than 1 minute. Okay, that's the local effect, that is called as gust. Lull is a period without waves or wind. So after the gust you will always see there is a silence. Okay, so that period is called as a lull. Okay, so gust is a change in a direction, increase in a wind speed, often with a change in the direction lasting less than 1 minute. Okay, so when you are actually flying the drone on the field, you may encounter this kind of situations over there. So you should able to differentiate whether this is a gust or whether this is what. Okay, so next slide will tell about the squall. Squall is a sudden increase in wind speed. Again, here the sudden increase in speed, often with the change in direction, but lasting for 1 minute or more. Okay, so this is more and can cover a wide area. Okay, so it could cover wide area, maybe 500 meters, even 1 kilometer of area. You could see all of a sudden the wind speed would increase. So it will last for more than a minute. In that scenario we call it as a squall. Okay, and we can see the squall coming. We can see the difference in the squall, because squall is not local, it is basically covering a wide area. So we can see all of a sudden the trees shaking, far off the trees, like almost 1 kilometer our visibility is there, or 2 kilometer visibility, we can see the trees, all the things flowing in the air and all the things. So when there is a squall, basically you should always try to land your drone as possible as immediately. Okay, so carelessness on the part of the squall can result in crashes of the drone, hence the loss. So you should always make sure that you land your drone as far as you see the squall prior it reaching to your location. Okay, now gull. Gale is basically the exist when the wind speed exceeds 33 knots. That means from your standard wind speed, so 15 knots is a very standard wind speed. Okay, if exceeds twice the standard speed, so it's almost double, 33 knots. So that is the when we call it as a gale. 4 times your standard wind speeds. So 15 fours are 60. So more than 60 knots, 63 knots, we call it as hurricane. So in that scenario, either it could be gale or it could be hurricane. In this scenario, normally we'll always avoid flying off our drones. Clear on these different types of winds? Gust is basically increase in wind speed, change in direction, but less than 1 minute, and it is only a local effect. The after the gust, whatever that silence period is there without waves or wind is called lull. Squall is again sudden and increase, change in direction of the wind lasting 1 minute or more, and it is covers a wide area. Okay, so squall is really important to be predicted because it covers more big area, and you can see it, you can physically see, because you'll see a lot of disturbance in the atmosphere or the location over there. Okay, we can't ignore the squall. Okay, so whenever we can see that wind is flowing in very huge direction, and disturbance is there in the atmosphere, we should always land our drone. 2 times your standard wind speed, which is called as a gale, 33 knots. 63 knots, that is the 4 times of your standard wind speed, is called hurricane. Okay, so anything above 63 knot is hurricane, and which where it will become very difficult to even aircrafts do not fly in hurricane conditions. Okay, this I have example, like I was giving you example of last time. Even in Mumbai, I was actually flying from Mumbai to Chennai. Okay, and I was sitting in the aircraft, and we were actually on the runway itself. We were waiting for clearance for takeoff, and all of a sudden the change of the atmosphere in Mumbai, all of a sudden. I mean, it was pretty clear, sunny. I was seeing it outside. I was having a window seat and I was seeing outside, and I was seeing it weather was good. And all of a sudden, there were some 2 3 aircraft ahead of us, and so we were somewhere on fourth or fifth in the queue. And all of a sudden, the change in the atmosphere, change in the weather, it started raining heavily. This is the same day. I'm talking about the same day when we had heard the news that there was a big hoarding which was fall, and some people died on that day. That's the same day. That day I was actually flying to Mumbai to Chennai, and all of a sudden my flight was delayed for almost more than 1.5 hour, 2 hours. Okay, so I reached Chennai very late. We reached Chennai very late, and uh, next day it was very clear in Chennai. Again, morning, as I said, I was there for that. I went from Chennai to Sriharikota for witnessing the Aditya launch, and then I had a visit to one of the university, Sriharikota, Sri City University. I had visited for some presentation over there on the drones. Okay, so and then end of my presentation there was all of a sudden again change in the temperature, change in the weather in the evening. Okay, so there was a huge rainfall. Almost for 2 hours it was raining over there also. So that's how you see the change in the weather. You can't really predict how the weather would be there. Like now, it could be very bright, sunny, and all of a sudden, after 4 hours, you might see it could be a very gloomy, or it could be a cloudy, or it could be even rain could start also. So depending upon the parameters, temperature, pressure, density, and the viscosity, I would say. Okay. Now let's see relationship between the speed units. Normally in standard aviation, we always refer the wind speed. Like though we are measuring in knots, ICAO standard is for the wind is basically kilometers per hour. So 1 knot is equivalent to 1.852 kilometers per hour. So when we say 3 knots means multiply by 3, 1.8. Okay, that could be the kilometers per hour. Some countries probably prefer in miles per hour, like UK or Canada, with locations where they are used. I mean, people who are familiar with miles per hour kind of terminology, so they will prefer. So again, that would be the conversion, like you need to do from 1 kilometer to 0.623 miles per hour. That difference would be there. So that's how you can do the conversion. But ideally for us in a drone world, we would currently only refer to the knots, because our limitation of the flight is within the range of 3 kilometers, 2 to 3 kilometers of range. Okay, so now after seeing the wind speed, let's see the clouds. So clouds is a mass of minute water droplets or tiny crystals of ice formed by the condensation of water vapors in a free air at a considerable elevation. As the clouds are formed at some height over the surface of the earth, they can take various shapes. Okay, you might have seen the clouds, but I don't know whether you are aware of how to differentiate different clouds. So this couple of slides will give you clarity to see the weather, and call out what type of clouds you are actually seeing. So there are four types of clouds basically. One is cirrus clouds, cumulus clouds, stratus clouds, and nimbus clouds. Okay, very simple way of defining the different clouds. So looking at the clouds, you will able to differentiate what type of clouds are there. So if you see, the cirrus clouds are formed at high altitudes, almost like 8,000 to 12,000 meters. They are thin and having a feathery appearance. They are always white in color. So you can see at the pictures, we have put some pictures of the cirrus clouds. So they are like feathery in appearance, white in color. Okay, they are always formed between 8,000 to 12,000 meters, and they are always white in color. So thin feathery appearance is the word which will differentiate this cloud. So this is called cirrus cloud. Whereas if you see cumulus clouds formed at a height of 4,000 to 7,000, they exist in patches, can be scattered here and there. Cumulus looks like a cotton wool. So this cotton wool, here it was feathery appearance. Okay, so seeing the difference in the appearance, it can tell you what type of cloud. So when you are seeing feathery appearance, these are cirrus clouds. When you see something like a cotton wool, they would be probably cumulus clouds. Okay. Whereas could be a stratus clouds. These are layered clouds covering the large portion. So this, if you see, these are very small locations, small area of the sky, whereas stratus clouds are covering the large portion of the sky. These clouds are generally formed either due to loss of heat or mixing of air with different temperatures. So this type of cloud formation you will start seeing now. Okay, now next 2 months you will see this type of clouds as we stay closer to the sea. Okay, so we'll see this type of cloud formation happening, stratus clouds formation. That's why we'll see always the weather would be more humid, we'll feel hotter, all that thing, because the temperature difference, the hot air, the cold air from the sea, they get mixed, and these weathers, the clouds are been formed. Whereas the nimbus during our rainy season, the nimbus clouds are black and gray. They form at middle level or very near to the surface. So they are very low lying clouds. Okay, very close to the surface of the earth. They are extremely dense and thick, so they don't have any shape. So they covers the entire area. So we don't see the visibility, we don't see anything. And probably if you have a more amount of nimbus cloud, probably it would start raining also. So you will see this kind of clouds forming at the start of the rainy season. We'll see the rain has appeared during June, that is around 7th or 10th June. Normally you will see this nimbus cloud started forming, and we'll have the rainy season starting in Mumbai, right? So depending upon different clouds and the position of the clouds, it could impact your US operations. So cloud base, less than 9,000 feet, distance to the cloud edge 2,000 feet, it could be impact your visual line of sight. Okay, so more or less, like if visibility is less than 3 miles, also will impact your visual line of sight. Fog, clouds, and precipitation, it can impact your airframe, short circuiting of electronics, because motor is a open structure. You can see the coil of the motors, and so it's open. Okay, so the the water vapors or all that things can go inside the motor and cause some kind of a electronic short circuiting kind of thing. Even in icing conditions, lot of time the icing would form, like if you're flying the drone in, like Ladakh region, or any European countries also, location where high altitude or high latitude locations, you will always see icing happening on the drone, which could probably impact the performance and also have a safety issues or loss of the aircraft. Okay, in lightning conditions, in the weather, in probably thundering or lightning situation, so there could be a drop in communication, radio frequency interference can happen also. So you should always avoid flying in these conditions. Okay, wind or wind shear, loss of control, inability to return to home, or mission failure also could happen. So normally whenever we see there is a huge flow of wind or wind shear is happening, or moderate or greater turbulence, we should immediately call off our missions, or maybe call off our flight plans. Okay, so if you see the cloud distance and the visibility, so if you are standing over here, so don't think from a perspective of miles, think from kilometer perspective. Okay, so this 0.5 miles you think as a 0.5 kilometer or 500 meters, I would say. So from your position you can see a drone very clearly. Okay, but as it moves away, see the drone would become more invisible. Okay, so you will lose the visibility. So if you see a standard for a normal human, the approximately 2 kilometer, 2.5 kilometer is a standard range where you can see the drone fly. Okay, beyond 2.5 kilometers, you can't see your drone. Okay, again it depends upon the size of the drone also. The bigger drone, maybe you get, like for example, you can see a aeroplane very far off aeroplane, right? Because the size of the aeroplane is very big. But if the aeroplane would have been smaller, like you can't see jet aeroplanes, because they are flying almost at 20,000 feet height. You can't see those aeroplanes, or since they are smaller compared to the normal civilian airplanes, and then they are more or less, sometimes they are black in color or gray in color, whereas your civilian airplanes are mostly painted in white in color. Okay, so that you have a better visibility of the aircraft. Okay, so as you move away and away from your location, you will see a denser fog. So that is how your visibility is there with respect to the distance. Okay. So any questions on this? So this is one of the questions which are being asked in Viva. Okay, a lot of people, I mean, a lot of students has been asked this question: what is the normal visibility when you are flying a drone? So nobody people think about. I mean, we had included this slide specifically to give you the idea what is the visual range of a normal person. Okay, so this was not there when we were having a training. So I have purposely included this slide just to give you an perspective about what is the visual condition. Every time I'm talking about VL loss, VL loss, VL loss, but what is VL loss? Okay, so when we talk about VL loss, is somewhere around 2 kilometer range or 2.5 kilometer of range. Beyond that, we can't see the drone, the normal drone. I mean, I can see a mountain 3 kilometers far, but because that mountain is a big structure, that's why I'm able to. But that is not my visibility. My visibility for the drone, I am saying it is only up to 2 kilometers, 2.5 kilometers max. Clear on this? Let's move ahead. Okay. Cloud and fog. Cloud and fog both forms when the water vapor condenses or freezes to form the tiny droplets or crystalline air. But cloud can form at many different altitudes, while fog only forms near the ground. So even the fog is the form of a cloud only. Okay, but it is just closer to the ground. We call it as a fog. Okay, but both are same. They are formed from the water vapors, because water vapors, when it condenses or freezes, it forms in a form of a tiny droplets or crystal in air. The fog is defined as a cloud with its base or at very near the ground. So we can see here in the picture, fog can caused by cooling. So there are two different ways of fog forming. In a cool air, as the air cools, it becomes denser and drains a lower areas such as river valleys where thick fog accumulation may occur. So in winter season, we would see this fog causing because of the cooling, right? A lot of time we see the fog happening, fog forming near uh, the cooler area, especially near the forest areas, or if you have a vegetation or good amount of trees and all these things. Okay, fog caused by evaporation. When the cool air moves over the warm water, enough moisture may evaporate from the water surface to produce saturation. So a lot of time, even because of the evaporation, like I don't know whether you people have gone for camping. Okay, so when you go for a camping, you might have seen a lot of times your tent getting wet from the outside. Okay, so that is basically because of the temperature difference on the tent. The inside temperature, as you are sitting inside the tent, you are breathing. The air inside the tent is more warmer compared to the air outside the tent. So you will see a water droplet forming on the tent. Have you encountered this kind of situation any point in time? So we always say the dew has formed, or the tent has become wet from outside, right? So icing again is one of the important aspect. Lot of time, lot of air crashes has happened into the civil aviation because of the aviation, because of the icing. And over the period of time, study has been conducted and icing and how does it impacts the air flying and all the things. It sometimes even blocks the sensors also on the wings. There are a lot of sensors on the wings, and this icing actually blocks and gives the wrong data to the autopilot, and based on that, autopilot might take a wrong decision in case of the icing. Okay, so the newer airplanes from Boeing or Airbus, they have a feature called as de-icing. Okay, so before actually the flight, from, like, let's say from Srinagar you are taking off the flight, normally pilot will always check the wings from his position, or maybe he will ask the ground crew also to check the icing on the wings. Okay, if there is icing, probably if they have a good aircraft with de-icing functionality, he will on the de-icing constantly. So it's basically nothing but the coils are there, thermal coils are there on the wings, which actually heats up the wing for certain temperature, and then it will evaporate or it will remove the ice formed on the leading or the upper surface of the wings. Okay. In case your aircraft, you have a smaller aircraft like Cessna is there, or your aircraft is not having a de-icing facility, you can always request a ground crew to put a hot water on the wing. So they will actually call a tanker with a hot water, which has a facility to make the water hot, and they will spray that hot water on the wings before the takeoff. Okay, so that's how you actually manage the icing into the locations, like especially in European countries or higher latitude locations. Okay, so how does that icing affects the structural of the flight? So effect of icings are cumulative. Like it will, your lift will decrease, weight will increase, the thrust will decrease, the drag will increase. Okay, so every time you have a buildup of the icing on the wings or on the fuselage or on the vertical and horizontal stabilizers, the overall performance of the aeroplane would impact. So it is always a duty of pilot to verify the aeroplane before putting it in the flying conditions from those locations, especially like high latitude or high altitude locations. Again, lightning can cause thunder, a sound wave from a shock wave which develops a gases in vicinity of discharge experiences sudden increase in pressure. Lightning occurs commonly due to thunderstorm as well as other types of energetic weather system, but also volcanic lighting, like in Thailand or those locations where you have active volcanics happening. So in that location also you will have lightning happening. This thing. So there was one of the civil aviation incident some years back where there was an aircraft which was flown from UK to Sydney. Okay, it was a four-engine aircraft which was flying, and when it was flying near Malaysia, Thailand location, there was an active volcanic eruption was happening, and because of that sulfur in the air, it has impacted the flying conditions. So there was sulfur formed, or sulfur those particles were there on the windshields. Okay, and it was impacting the visibility of the pilot, as well as those sulfur particles have gone inside the your engines, and all of a sudden, one by one, all the four engines failed. Okay, so all the four engines stopped working, and miraculously the pilots actually were able to, there is an episode on this particular situation what I'm telling you. You can watch it on YouTube, or even in the air crash investigation series also you can see. uh, the pilot was able to land this plane without four engines. So one of the passengers from Australia, who was actually part of that flight, has written a book on this entire incident. Uh, Again, that is a best-selling book, author book. Okay, where it has narrated about the complete incident and how uh, pure flying skills has helped to land plane safely, and all the passengers were safe after the landing. Okay, so without engine, the pilot was able to land because fixed wing aeroplanes or the aeroplanes can glide. Okay, so he actually corrected his flight plan. He had a plan where he can land the plane and all the things. So that's how where the importance of your piloting skills or your experience comes into the things when it is in emergency situations. Okay, wind shear. Wind shear are sometimes referred to as wind gradient. Is a difference in the wind speed or in direction over the relative short distance in atmosphere. Atmospheric wind shear is normally described either in vertical or horizontal wind shear. So vertical wind shear is change in wind speed or direction in change in altitude. That means you can see the change in wind speed with respect to the altitude or height, whereas horizontal wind shear is change in the wind speed with the change in the lateral position for a given altitude. If you see the diagram, the vertical wind shear, you can see here there is a change in altitude. Okay, so wind speed change with the respect to the altitude, we call it as vertical wind shear. whereas change in the wind speed with respect to the lateral position from one location to other location in a horizontal direction, that is called as a horizontal wind shear. Clear? So what is turbulence? Turbulence is nothing but a short, violent shift in airflow caused because of the wind, storm, or jet stream object near the plane, particularly the mountain ranges. So you will feel a lot of time when you are flying. You're flying, like especially when I was flying between Mumbai to Delhi. I'll always see that near somewhere Jaipur or Rajasthan area, I will always see there is a turbulence. Okay, so pilot will try to avoid a turbulent path or something, or he will either he will climb up or he will descend over there. Okay, so depending upon ATC instructions, he will take the decision, and he can drop. So let's see how the turbulence would affect. So light turbulence momentarily cause the slight change in altitude or attitude or a slight bumpiness. Occupant of the airplane may feel slight strain against the seatbelt. I mean, that's a normal turbulent. Okay, we normally see that turbulence. But moderate turbulence is similar to the light turbulence, but somewhat more intense. There is, however, no loss of control on the airplane. So light and moderate are manageable, but severe turbulent. Okay, if you see severe turbulent, there is a rise or drop of 30 meters in your plane. So this is the time when you would be told, mostly during the moderate scenario itself, the pilot will ask you to return to your seats and fasten your seat belts. The flight crew would probably stop serving you the food and beverages and all that things. Okay, whereas light you don't need. Okay, hardly noticeable, because okay, but moderate, probably people would just say you be on your place, don't use washrooms and all the things. But in severe, everything is stopped. So that is the time when it is critical. Will where even the crew would be sitting at this type of turbulence. Okay, you would have encountered this kind of situations in your regular traveling, right?
Yes.
Okay. So with that, we complete our topic of weather and meteorology. Any questions so far on weather on meteorology? Anywhere you find anything which you have not understood, not clear? I mean, it is very simple. Important is what is the international standard atmospheric pressure. Mean sea level temperature is 15 degrees. Mean sea level pressure is 1013.25 hectopascal. Mean sea level density is 1225 grams per cubic meter. The lapse rate is very important. Okay, that is 2 degree per thousand feet. Okay, this is again important part. Then METAR. How do you read the METAR? Now, because of advancement of technology, very simple METAR is available, or even apps are available to understand the temperature. So earlier, in olden days, 10-20 years back, people used to use METAR to understand the weather condition or meteorological conditions for flying. Okay. Okay, so we'll take a break. It's already 1:15 now. So we'll come back at 1:15, and we'll start with a topic called drone equipment and maintenance. Okay?
Okay, we join at 2:15, right?
Yeah, 2:15 after 1 hour exactly.
Okay.
Okay? Okay then.
Yo.
Thank you. I'll just log off.
Answer